Good morning, students. As we have seen that continuity means continuous. Okay, we have already discussed this concept in 11th standard also. That continuous means, in simple way, we can say that if we draw a graph without lifting a pen, then the function is called continuous function. Now, mathematically, how can we check whether the given function is continuous or not? So here, to check the continuity of the function fx equals to 2x plus 3 at x equals to 1, what we need to do is we have to check the value of function in neighborhood of x is equals to 1. Now, neighborhood of x is equals to 1 means we will consider if we see the different value of function at different value of x, but it should be closer than 1. That means we can take x is equals to 0.9. We can also take x is equals to 0.99. Then we can take x is equals to 1. We can also take x equals to 1.01 or 1.001. And if that value is also closer to some fixed value, then the function is continuous. And as we all know that linear function is always continuous. So here the function is, we need to check whether the function is continuous at x is equals to 1 or not. Now when we consider the value of x slightly less than 1, that is called left hand side limit. And when we are considering value of x slightly greater than 1, that is called right hand side limit. So here limit x tends to 1, f of x is equals to, basically actually what we will do, we are not going to change the value. Simply what we will write here, x tends to 1, 2x plus 3. So we will put 1 instead of x. So value of function is 5. Here also f of 1 is 5. Okay, why? Because we know that the function is continuous if limit x tends to 1, f of x is equals to f of 1. Okay, now we know that. Now instead of finding left hand side limit and right hand side limit, simply we can also put here x is equals to 1, right? So when we put x is equals to 1, left hand side of this statement becomes 5. Similarly, right hand side is also becomes 5. So we can say that the function is continuous. Now if we see that fx equals to 5x minus 3 is continuous at x is equals to 0, at x is equals to minus 3, and at x is equals to 5. Now remember, x is equals to 0 to check whether it is continuous or not at the given point. Okay, here x equals to 0, x equals to minus 3 and x equals to 5 are the given points. So for x is equals to 0, limit x tends to 0, f of x is equals to f of 0. If we can prove this much, then we are done. We can say that the function is continuous at x is equals to 0. Now as you all know, 5x minus 3 is a linear function. Okay, so instead of finding left hand side limit and right hand side limit, directly we'll find limit x tends to 0. And limit x tends to 0 will be 5 multiplied by 0 minus 3, that is minus 3. And f of 0 will also be minus 3. So we can say that f is continuous at x is equals to 0. Okay, here you can see the solution. Now the same sum we have to check for x is equals to minus 3, right? So when x is equals to minus 3, the function is linear. So directly we are putting x is equals to minus 3 here. So answer, left hand side is also minus 18, right hand side is also minus 18. Hence the function is continuous at x is equals to minus 3. Similarly, for x is equals to 5, you can check, and as the function is linear, it is going to be a continuous function. Now, here we want to check the continuity of fx equals to 2x square minus 1 at x is equals to 3. So again we have to find limit x tends to 3, f of x equals to, we need to prove this, that limit x tends to 3, f of x is equals to f of 3. So to find out limit x tends to 3, f of x, we will put x equals to 3 in the polynomial. So again LHS equals to RHS. This concept is very simple as we have already spent lots of time to find the limit, right? So we know how to find the limit. Now simply we are placing the value of given value of x in the polynomial. Okay. So through this example we can say that all the polynomials when their domain and codomain, okay, both are R, they are continuous. Okay. Now here we have the step function. We have different two functions are there. Fx equals to x cube plus 1 if x is not equals to 0 and is equals to 1 if x equals to 0. Okay, so when we find limit x tends to 0, we will put x equals to 0 here. Why? Because limit x tends to 0 doesn't mean x equals to 0. Okay, we are approaching 0, but x will not be 0 when we are finding limit. Okay, so whatever value we are getting, limit x tends to 0, that is not for exact x equals to 0. Okay, just we are going near to the 0. So that value will be 3 here. See here, limit x tends to 0 will be left hand side limit, right hand side limit, right? So let us find out here limit x tends to 0. So that is going to be left hand side limit and right hand side limit. Why? Because x is 0. So for when we are very near to 0, the value will also be closer to 0, right? And value will approximately 3. So left hand side limit and right hand side limit will be 3. Okay, so f of 0 is equals to 1, right? So here limit is not equal, left hand side right hand side limits are equal but is not equals to f of 0, therefore f is not continuous at x is equals to 0. Similarly here we have another question, that is the function given function when x is less than or equals to 1 we will consider x, and if x is greater than 1 we will consider 5, is continuous at x equals to 0. So when we find limit x tends to 0, that is less than 1, right? X is equals to 0 means that will fall in this category. So answer will be 0. Okay, because we have to consider f of x equals to x. So when we are talking about x equals to 0 and fx equals to x is a polynomial, it is continuous and therefore the function is continuous. Now next part of the same question was 5 if x is greater than 1, and we want to find that x equals to 1 and x equals to 2 whether it is continuous or not, right? So for x equals to 1, when we will find the left hand side limit and right hand side limit. So for left hand side limit we have to take when x is less than 1, right? So that is going to be this type of equation you will get, that is limit x tends to 1 minus, so 1 minus h, but h is 0, so it is 1, or simply you can take 1 also if you are very comfortable with limits. Now when we are finding right hand side limit means we will consider value of x slightly greater than 1, so we have to consider the next definition, that is 5. So they are not equal, therefore it is not continuous at x is equals to 1. When x is greater than 2, sorry, greater than 1, so x equals to 2 falls in that category. Okay, so value is not going to be changed, so fx equals to 5, hence fx is continuous for x equals to 2. Now in next online lecture we will learn about we will see the more examples. Thank you. Bye bye.